Last episode, we built the skeleton, a dumb loop with a model adapter, a tool executor, and a flat event log. But that agent forgets everything the moment its context fills up, and it has no idea how to plan. Let's give it a brain. Start with the hardest constraint in the whole field. The context window is finite, and it gets dumb before it gets full. Quality degrades, looping hallucinated tool calls well before you hit the token limit. So, context isn't storage you fill to the brim, it's an attention budget you spend carefully. That means two kinds of memory, not one. There's the in context transcript, fast but it evaporates when you compact or start a new session. And there's durable memory, files on disk the agent reads back. Client's memory bank is the clearest example. 6 markdown files, project brief, active context, progress, that the agent rereads at the start of every task to rebuild its understanding without burning a single conversation token. Claude Code does the same with one file, claude.md, re-injected on every request. When the desk does fill up, you compact. Goose summarizes old turns automatically at 80% of the window. OpenHands uses stateless condensers that keep the full log on disk but only summarize when building the prompt, reportedly cutting cost roughly in half with no measured quality loss. Lightest touch first, clear old tool outputs before you summarize real reasoning. Now, planning. The single best safety and focus move is to split deciding from doing. Client's plan and act modes do exactly this. Plan mode is read only. The agent can read and search and discuss but cannot write or run anything. Act mode unlocks the full tool set. The plan conversation just carries over as context. You separate the thinking from the hands, and you get a reviewable decision trail before anything destructive happens. Let's wire all of this into our blueprint. Same diagram as last episode, but now the purple inner harness zone lights up. Watch how data flows for a single turn, left to right, then back. First, context assembly. Before every model call, an assembler gathers 4 things: the system, prompt, and durable files like our memory bank, a just-in-time slice of retrieved repo knowledge, the recent transcript, and the current plan. It packs them into one prompt and checks the budget meter. If the meter is near full, the compactor fires. It summarizes the oldest turns into a digest, drops stale tool outputs, and keeps the recent exchanges verbatim. The full history still lives in the event log on disk, only the prompt shrinks. This is the difference between forgetting and filing. Next, the memory store, files on disk, off to the side. The agent writes notes to it during a task and reads them back at the start of the next one. This is the loop's long-term memory, and it survives compaction, crashes, and fresh sessions because it isn't in the context window at all. Now tools. Every tool, built-in, custom, or from an external MCP server, registers in one registry as a schema plus a handler. Goose makes this its whole philosophy. Everything is an MCP tool on a universal bus. Crucially, an MCP tool's JSON schema auto-translates into the same shape as a native tool, so the model can't tell them apart. And every call passes through a permission gate first, allow, deny, or ask, before it ever runs. Finally, the planner and the reflection loop sit on top of the loop. In plan mode, the agent proposes. In act mode, it executes. And when a step fails, a test breaks, and edit doesn't apply, the reflection loop feeds the error back in with the relevant code context and lets the agent try again. Aider does this with lint and test failures. The research idea is reflection. Reflect on the failure, then retry smarter. Now our agent has a brain. It remembers, it manages its own attention, it reaches for tools through one gate, and it plans before it acts, but it still can't safely touch the real world. Next episode, sandboxed execution. Git is the undo button, retrieval over a real repo, the security defenses that stop it from leaking your secrets, plus eval and deploy, and then we ship it. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.